Solving systems of linear equations by addition. All right, so when we have two equations, we can try and add them together to make one equation. Now, right off the bat, I see plus y and minus y. So as you'll see when we add these together, we have x plus x, which gives us 2x, and then plus y minus y. So the y is gone. They're canceling each other out. And equals 14 plus 10. So 24. Now we can get x alone by dividing out the 2 on both sides. And we're left with x equals 24 divided by 2, which is 12. Now we can plug this 12 back into either of our equations. I'll just use the top one. So take our x, 12, plus y equals 14. Get our y alone, subtract out 12 from both sides, and we're left with y equals 2. And here's our next problem. And so looking at these two, the first thing I want to do is figure out how can I add these together and make one of my variables cancel the other. And the first thing I'm thinking up here is I could multiply both sides of my top equation by -3 in order to get a -3y here to cancel out the 3y on the bottom. So if I multiply both of these by -3, and I come over here, and I have -6x, or actually positive 6x. And now that plus is a minus, so minus 3y equals -3 times 2, -6. And now I'm going to rewrite my bottom equation over here also so I can add them together. And I have minus x plus 3y equals -4. So let's put these together. We have 6x minus x, which is 5x. The 3y and the -3y cancel, and we just have -6 minus 4, which is -10. Now get our x alone. Divide out the 5 on both sides, and we find that x equals -2. Now we can plug that -2 into any of our equations. We'll do the bottom one. So we have negative times our x, which is -2, plus 3y equals -4. Negative times -2 is just positive 2, plus 3y equals -4. Subtract out our 2 on both sides to get 3y alone. We're left with 3y equals -6. Divide out the 3. 3's cancel. And we're left with y equals -2. And when you go to write your answer, your teacher's probably going to want it like this. Like coordinates on a graph. So -2, -2, and that would be your answer. Okay, so here's an interesting case you could possibly run into. You see that we have 3x minus y equals 6 and -3x plus y equals -6. So if we add these together, 3x minus 3x, we get 0, plus -y plus y, which is 0, and equals 6 minus 6, again 0. So we have 0 on both sides. And what this means is that it's a true statement, or there's an infinite number of solutions, and if we were to graph these, they would be the same exact graph. Because if you see, all I would have to even do to this bottom equation, or I could do it to the top equation, is multiply it by -1, and I would end up with the top equation. Negative 1 times negative 3x is 3x. Negative 1 times a positive y is minus y. And negative 1 times negative 6, you'll get positive 6. So it's the same as the top equation. This is a true statement, meaning it has infinite solutions, and both of the graphs are the exact same. All right, this will be our last equation and the most important trick of all of them. So I want to add these together in a way that I can get rid of one of our variables. And I'm looking at this 4y negative 9. You could do it with the 3x and 5x if you want it, but I'm going to do it with 4y negative 9y. I can multiply this top equation by the number in front of my y down here, the 9. And I'm trying to make my y's the same, so they cancel out. Or 1 minus and 1 positive, but the same number. And I can multiply the bottom one by my number up here, 4. To get them to be the same. And this will be 9 up here. So 9 times 3x will give us 27x. I'll write that over here. 27x plus 9 times 4y, 36y, equals 13 times 9, which comes out to 117. And on the bottom, 4 times 5x is 20x. We're going to add that to, let me make this better. Add that to 4 times minus 9y, which is minus 36y. And that equals 4 times 6, which is 24. Now my y's are canceling. If I add these two equations together, 27x plus 20x is 47x. 36x and 36x cancel, equals 117 plus 24, which comes out to 141. Now I divide by 47 over here to get x alone, and divide by 47 on the right side, keep things balanced, and I find that x equals 3. Now I can just go back and plug this into one of my original equations. We'll do the 3x plus 4y. So 3 times our x, which is 3, plus 4 times y equals 13. 3 times 3 is 9, plus 4y equals 13. Get 4y alone by subtracting out the 9 on both sides. We're left with 4y equals 4. Divide out the 4 to get y alone. And we get y equals 1. And our solution would be written as, like you would write coordinates, because they are coordinates. So you would put your x first, 3, and your y second, 1. And this is your answer. All right, thank you for watching. If you have any questions, please leave them down below in the comments section.